Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about hydraulics machine, reciprocating pump. Stored energy of fluid is also termed as hydraulic energy, and hence pumps are basically defined as the hydraulic machines which convert the mechanical energy into hydraulic energy. What is a reciprocating pump? If the mechanical energy is converted into stored mechanical energy or pressure energy by sucking the liquid into a cylinder in which a piston is reciprocating backward and forward, which exerts the thrust on the liquid and increases its hydraulic energy or pressure energy. The hydraulic machine will be termed as reciprocating pump. Reciprocating pump is a positive displacement pump where certain volume of liquid is collected in enclosed volume and is discharged using pressure to the required application. Reciprocating pumps are more suitable for low volumes of flow at high pressures. Components of reciprocating pump. The main components of reciprocating pump are as follows: a cylinder with a piston, piston rod, connecting rod, crank and crankshaft. Suction pipe, delivery pipe, suction valve, delivery valve, strainer. A cylinder with a piston, piston rod, connecting rod, crank and crankshaft. Cylinder. A hollow cylinder made of steel alloy or cast iron. Arrangement of piston and piston rod is inside this cylinder. Suction and release of liquid takes place in this, so both suction and delivery pipes along with valves are connected to this cylinder. Piston and piston rod. Piston is a solid type cylinder part which moves backward and forward inside the hollow cylinder to perform suction and deliverance of liquid. Piston rod helps the piston to its linear motion. Crank and connecting rod. Crank is a solid circular disc which is connected to power source like motor, engine etc. for its rotation. Connecting rod connects the crank to the piston. As a result, the rotational motion of crank gets converted into linear motion of the piston. Figure indicates the single-acting reciprocating pump. Piston will move within a cylinder in forward and backward direction towards inner dead center and outer dead center, i.e. piston will execute the reciprocating motion within the tight-fit cylinder. Reciprocating movement of piston within tight-fit cylinder will be executed by connecting the piston with crank with the help of connecting rod as displayed in figure. Crank will be fixed with crankshaft which will be rotated by an electric motor. Suction pipe and suction valve. Suction pipe connects the source of liquid to the cylinder of the reciprocating pump. The liquid is sucked by this pipe from the source to the cylinder. Suction valve is non-return valve, which means only one directional flow is possible in this type of valve. This is placed between suction pipe inlet and cylinder. During suction of liquid it is opened and during discharge it is closed. Delivery pipe. Delivery pipe connects cylinder of pump to the outlet source. The liquid is delivered to desired outlet location through this pipe. Delivery valve. Delivery valve, also non-return valve, placed between cylinder and delivery pipe outlet. It is in closed position during suction and in opened position during discharging of liquid. Strainer. Strainer is provided at the end of suction pipe to prevent the entrance of solids from water source into the cylinder. Suction pipe and delivery pipe will be fixed with the cylinder by means of suction valve and delivery valve respectively, as displayed in above figure. Suction valve and delivery valve will be check valve, i.e. non-return valve, and hence water may flow in one direction only through these valves. When piston will move towards right, i.e. towards outer dead center, there will be fall in pressure of liquid and hence due to reduction in pressure suction valve will be opened and liquid will enter into the cylinder. When piston will move towards left, i.e. towards inner dead center, there will be increase in pressure of liquid and hence due to increase in pressure of liquid suction valve will be closed and delivery valve will be opened and liquid under high pressure will flow through the delivery valve to delivery pipe of reciprocating pump. Working of reciprocating pump. When piston will move towards right, i.e. towards outer dead center, there will be fall in pressure of liquid and hence due to reduction in pressure suction valve will be opened and liquid will enter into the cylinder. This movement of piston inside the cylinder will be termed as suction stroke. When piston will move towards left, i.e. towards inner dead center, there will be increase in pressure of liquid and hence due to increase in pressure of liquid suction valve will be closed and delivery valve will be opened and liquid under high pressure will flow through the delivery valve to delivery pipe of reciprocating pump. Working. When the cranks start rotating, the piston moves in the cylinder. From the diagram, when a crank is at A, the piston is at the extreme left position in the cylinder. As the crank is rotating from A to C, theta equals 0 degrees to theta equals 180 degrees, the piston is moving towards the right in the cylinder. The movement of the piston towards the right creates a partial vacuum in the cylinder. But on the surface of the liquid in the sump atmospheric pressure is acting, which is more than the pressure inside the cylinder. Thus the liquid is forced into the suction pipe from the sump. This liquid opens the suction valve and enters into the cylinder. When a crank is rotating from C to A, theta equals 180 degrees to theta equals 360 degrees, the piston from the extreme right position starts moving toward left in the cylinder. The movement of the piston towards the left increases the pressure of the liquid inside the cylinder more than the atmospheric pressure. Hence, the suction valve closes and the delivery valve opens. The liquid is forces into the delivery pipe and is raised to a required height. Summary for working of reciprocating pump. When the power source is connected to crank, the crank will start rotating and connecting rod also displaced along with crank. The piston connected to the connecting rod will move in linear direction. If crank moves outwards, then the piston moves towards its right and create vacuum in the cylinder. This vacuum causes suction valve to open and liquid from the source is forcibly sucked by the suction pipe into the cylinder. When the crank moves inwards or towards the cylinder, the piston will move towards its left and compresses the liquid in the cylinder. Now, the pressure makes the delivery valve to open and liquid will discharge through delivery pipe. When piston reaches its extreme left position, whole liquid present in the cylinder is delivered through delivery valve. Then again the crank rotate outwards and piston moves right to create suction, and the whole process is repeated. Generally, the above process can be observed in a single acting reciprocating pump where there is only one delivery stroke per one revolution of crank. But when it comes to double acting reciprocating pump, there will be two delivery strokes per one revolution of crank. Discharge through a reciprocating pump. Let us consider the following terms as mentioned here for a reciprocating pump displayed above in figure. D equals diameter of the cylinder. A equals cross-sectional area of the piston or cylinder. R equals radius of crank. N equals RPM of crank. L equals length of the stroke equals 2 times R. H S equals suction head or height of the cylinder axis from the water surface in the sump. H D equals discharge head or height of delivery point from the cylinder axis. Volume of water delivered in one revolution equals area times length of stroke. Volume of water delivered in one revolution equals A times L. Number of revolution per second equals N/60. Volume of water delivered per second equals volume of water delivered in one revolution times number of revolution per second. Volume of water delivered per second equals A times L times N/60. Volume of water delivered per second equals A times L times N/60. Discharge of the pump per second equals A times L times N/60. Work done by reciprocating pump. Work done by reciprocating pump will be given by following equation as mentioned here. Work done by reciprocating pump equals weight of water lifted per second times total water through which water is lifted. Work done by reciprocating pump equals ρ times G times discharge of the pump per second times total water through which water is lifted. Work done by reciprocating pump equals ρ GALN times HS plus HD, 60. Unit is kilowatt, kW. Classification of reciprocating pump. Follow are the three fields in which the reciprocating are classified. According to the contact between water and plunger. According to the number of cylinders. according to the contact between water and plunger single-acting pump. A single-acting pump is one which has one suction valve, delivery valve, and one suction and delivery pipe. It sucks up the fluid only in one direction and in single stroke called suction stroke and deliver it in a single stroke called delivery stroke. Double-acting pump. A double-acting pump is one which has two suction valves, delivery valves, and two suction and delivery pipes. If we suppose that piston is in the center of the cylinder, then one suction and delivery pipe is on one side and one delivery and suction pipe is on other side of the piston. Water will be acting on both sides of the piston in case of double-acting reciprocating pump. Therefore, there will be two suction and two delivery pipes for double-acting reciprocating pump. When there will be a suction stroke on one side of the piston, same time there will be a delivery stroke at the other side of the piston. Hence, in case of double-acting reciprocating pump, there will be two suction strokes and two delivery strokes for one complete revolution of crank, and water will be discharged through the delivery pipes during these two delivery strokes, according to the number of cylinders. One single-cylinder pump. Single-cylinder pump is one in which there is only cylinder connected to a single shaft. It could be a single-acting or double-acting pump. Two double-cylinder pump. Double-cylinder pump is one which have two cylinder attached to a single shaft. Separate suction and delivery valve is provided to each cylinder. Crank of the pump is set at an angle of 180 degrees. 3 triple-cylinder pump. When the pump has 3 cylinders attached to a single shaft, then the pump is called triple-cylinder pump. Crank is set at an angle of 120 degrees. Slip in reciprocating pump. Slip in reciprocating pump is basically defined as the difference between the theoretical discharge and actual discharge of the reciprocating pump. Actual discharge of a reciprocating pump will be less than the theoretical discharge of the pump due to leakage of water during operation of pump. The difference of the theoretical discharge and actual discharge will be called a slip of reciprocating pump. Mathematically, we can express the slip in reciprocating pump as mentioned below. Slip equals Q. Q. Act. Slip is usually expressed as percentage slip, and it will be given by following expression, where C D equals coefficient of discharge. Negative slip in reciprocating pump. As we have discussed above, that slip in reciprocating pump is basically the difference between the theoretical discharge and actual discharge of the reciprocating pump. If actual discharge is more than the theoretical discharge, slip of the reciprocating pump will be negative, and it could be concluded by considering the equation of slip of reciprocating pump. Negative slip will occur when suction pipe is long, delivery pipe is short and pump is running at high speed. Advantages and disadvantages of reciprocating pump. Following are the advantages and disadvantages of reciprocating pump. Advantages of reciprocating pump. High efficiency. No priming needed. Can deliver water at high pressure. Can work in wide pressure range. Continuous rate of discharge. Disadvantages of reciprocating pump. More parts mean high initial cost. High maintenance cost. No uniform torque. Low discharging capacity. Pulsating flow. Difficult to pump viscous fluid. High wear in parts. Difference between reciprocating pump and centrifugal pump. Serial. No. Reciprocating pump. Centrifugal pump. 1. The discharge is fluctuating and pulsating. Here, the discharge is continuous and smooth. 2. Reciprocating pump handles a small quantity of liquids. The centrifugal pump handles large quantity of liquids or fluids. 3. It is used for only pure water or less viscous fluid. It is used for only pure water or less viscous fluid. This can be used for lifting highly viscous fluid. Serial. No. Reciprocating pump. Centrifugal pump. 4. It is used for pumping high viscous fluid. It is used for pump low viscous fluid. 5. In this pump's discharge is inversely proportional to the viscosity of fluid. In reciprocating pump, viscosity of fluid does not affect the discharge rate. 6. Efficiency of these pumps are low compared to reciprocating pump. Efficiency is high. 7. Centrifugal pump have problem of priming. It does not have any problem of priming. 8. It uses impellers to transfer energy to fluid. It uses piston cylinder device to transfer energy to fluid. 9. They are lighter than reciprocating pumps. These are heavier compared to centrifugal pump. Serial. No. Reciprocating pump. Centrifugal pump. 10. It gives higher discharge at low heads. These gives higher heads at low discharge. 11. It is less costly. These are costly. 12. These pumps required less maintenance. These required higher maintenance. 13. Centrifugal pumps are easy to install. These required less floor space. These pumps are difficult to install. These required more floor area. 14. It is mostly used for domestic purpose and where a higher discharge outlet required. These are mostly used in industries and high viscous fluid pumped at a high head. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.